So what are the basic things that most OSs do, mobile OSs do, in terms of helping enforce security? Like what are these features in these perhaps somewhat immature OSs that you mentioned that developers can take advantage of?
Sure. So, I'll cover two at a very high level. We'll talk about just application sandboxing, first of all. And that basically means that your application is running on the device and it's in its own protected sandbox. It can potentially write to the file system, and it can write and read to its own files, but it can't necessarily touch the files of another application. So if your banking application is storing some sort of potentially sensitive data on a file, the newest game that you've downloaded can't necessarily out of the box reach in and touch and read those bits of data. The operating system won't let that happen. Now, when the device is jailbroken, those controls are removed. And now a rogue or malicious application running on the device is running at a higher privilege level and can potentially do a lot of things. It can attack other applications. It can abuse other bits of functionality on the phone, like turn on the microphone, for example, or steal your contacts or send out SMS messages or email. The other bit that I'd like to talk about would be secure data storage. So I've already talked a little bit about just data storage on the device, writing to files. You don't want to, if you're, for example, storing credentials on the device, or you have the need to store credentials on a device so a user doesn't need to enter them every time they authenticate to your app, you don't want to just write them to a flat text file in plain text on the device. Something like that is easily recoverable. Whether or not the device is jailbroken, and we're talking about applications attacking it, if the person loses their device, you don't want somebody to be able to pick it up and with minimal skill or ability be able to pull a file off your device, and now they have your banking credentials. So the platforms provide certain methods of securely storing data on the devices. For example, on iOS, there's the keychain. Data stored in the keychain isn't necessarily encrypted unless the user has a passcode on their device. So if they don't have a passcode on their device, and you're, as a developer, you're storing something in the keychain, and the device is not jailbroken, you have the application sandboxing. So my app can't access your app's credentials. But if an attacker picks up the device and has physical access to it, he can get at that keychain data, and it's not protected without the passcode. So there are lots of little nuances that people need to be aware of.
Do you think developers are commonly aware that this sort of scenario exists, for instance, on an iOS, on the iOS platform?
I think the documentation could always be improved upon, and there's a lot of just general awareness that needs to happen. It's also very easy to go down the encryption rabbit hole, where we know we need to protect this data, so let's encrypt it, and we'll use a symmetric key. And you come across that quite often when you're reviewing mobile applications, where you just happen to find a hard-coded crypto key right in the application code base, used to store the credentials in the file system encrypted. But what the developers don't always realize is that that key is easily recoverable, and in that case, now the key is on 1 million devices for the 1 million users who've installed your application. So now you've got a situation where a bad guy can say, I see how poorly this app is protecting this sensitive data. I can see, based on the number of downloads, that it's installed on, bazillions of devices. Now I can target this application, and I can write a Trojan or some piece of malware that'll, masquerade as a legitimate mobile application, and seek out this other app on the installed user base.